Okay, so we're going to solve this equation using the homogeneous approach. This is a problem I previously solved using the exact method with integrating factors, but we're going to try to solve it as a homogeneous problem since all the polynomials in our expression are the same degree. So we can test to make sure this works by substituting everything there where there's an x for tx, and every place there is a y for ty. And when we do that, 3xy becomes 3tx ty, and y squared becomes t squared y squared, and x squared is t squared x squared, and xy is tx ty. And we can factor out two t's, t squared, out of every single one of these terms. And we can see that after we factor t squared out all the way, there are no t's left over. And so this tells us that this problem is in fact solvable by using this substitution for homogeneous problems. So recall from our homogeneous solution problem previous example, the substitution we're going to make is y equals vx. That means if v is a function of x, and so when we take the derivative to find y prime, we have to use the product rule. So v prime x, and then vx prime, but the derivative x with respect to itself is 1. And we'll use this to get back to x and y from our solution in terms of v. In order to solve this problem as a homogeneous, we are going to solve the equation in terms of dy dx. And so the first thing that I did was I moved my first term here over to the other side of the equation, and I distributed the negative sign. That's why the terms are flipped. And then I'm going to divide by this parentheses over here, and I'm going to divide by dx. And so I get my dy dx is some function of x and y. And now I'm going to make my substitution. So y prime becomes v prime x plus v. And everywhere there was a y gets replaced with vx. So y squared becomes v squared x squared. The y introduces another x, and so 3x squared v. Same thing in the bottom, x squared doesn't change, but I get an extra x from my substitution for y. And then I factor out my x squareds, and this is what is supposed to happen. You cancel out the same number of x's as you originally had t's factored out. And so we're left with this expression only in terms of v. Now, to proceed with solving it, I have to move this v to the other side of the equation. So I do that here, my previous right side minus v, and then I have to find a common denominator, so I can add these together and make one single fraction. So I multiplied top and bottom. I distributed my negative v, so negative v times 1 and negative v times negative v is plus v squared. V squared and v squared is 2v squared. Negative 3v and minus v is negative 4v. And then I can factor out 2v to get this. And you can see nothing cancels here. So v prime x is equal to this. And so what I need to do is, this is separable now. So I need to separate it and put all the v's on this side, and I will do that by multiplying by the reciprocal, although I'm going to leave the 2 behind. So I get this. And then I'm going to divide by x, and I'm going to multiply by dx. And these are now separated expressions. They have only one variable on each side of the equation, and so I can go ahead and integrate. Now, this side of the equation is no big deal. I just get 2ln x plus c. But this side of the expression is going to need to be integrated using partial fractions. And so I've separated here my factors into 2 terms. I find my common denominator by multiplying a times v minus 2 and b times v and adding them together. And then I want to set equal to each other the coefficients for v on this side with the coefficients for v on this side. And same thing for the constants on this side with the constants on that side. So the v's are a plus b is equal to -1, which was this minus v up here. And then the constant on this side is -2a, and that is equal to 1. And so this one's easy to solve. That gets me this. And then if I solve for a plus b equals -1, then b also has to be -1. And so I substitute this expression with my a and b where my complicated rational expression was before, and now I can easily integrate using log rules. And so I get this. And so now what I need to do is I need to just do a bunch of algebra. I'm going to multiply by -2 everywhere in order to get this. And I've rewritten my c here initially in terms of -2 times c gives me a d. But I want to combine everything into a single log expression on each side. So, note that d is the same thing as ln e to the d. I can cancel these if I wanted to. But that allows me to merge these together. And if I let e to the d equal to h, I get this after I use the power rule to bring the -4 inside the log. And here I'm using the product rule for logs by taking these sums and turning them into a multiplication inside a single log. And then I can cancel my logs. And when I do that, I'm left with this expression. And again, I've just put the x to the -4 in the denominator. I multiply out my v's. And then back when we introduced our substitution, we said we were going to need this part later. Here we're going to substitute back in our y over x. So v squared becomes y squared over x squared, and 2v becomes -2 times 1y over 1x. Okay, and then we want to get rid of the denominator, so we're going to multiply everything by x to the 4th. And when we do that, we're going to get this expression, which is looking somewhat similar to our previous solution, but it's not quite exactly the same. So what we're going to do is I'm going to multiply everything by -1/2. And when I do that, this -2x cubed y becomes positive x cubed y. And this term will become -1/2 x squared y squared. And then this h will become some other arbitrary constant. And in fact, our solution in the exact integrating factor video was this solution without this expression. So these methods are equivalent to each other, and you can use them to solve sometimes the same equation. But there will be other occasions where you won't have two methods, two options available. You'll only have either homogeneous or the method of integrating factors. And you should use, if you have a choice, use the one that you find the most simple, to the one you're most familiar with. But you should know them both separately, because there will be cases where they are not completely interchangeable.